In this question, the quantity of both reactants, one is magnesium hydroxide and the other is hydrochloric acid. You see, the quantity for both reactants are given. Whenever that's the case, we know one of the two must be the limiting reactant, and we need to find out the limiting reactant first. In order to do so, we have to follow the guidelines you learned previously from lecture 22. This is the slide number 7 in lecture 22. Guideline number 1, convert the mass or mole amount of each reactant to the mole amount of the desired product. That's step number 1. And you need to do that for both reactants in this question. So first, let's work on magnesium hydroxide. We know the quantity in grams for magnesium hydroxide, 1.10 grams magnesium hydroxide. We convert from grams of magnesium hydroxide to moles of magnesium hydroxide using the molar mass. 1 mole of magnesium hydroxide contains 58.3 grams. Okay? So according to the guideline number 1, we need to convert the mole amount. So now you see grams and grams are cancelled. We have the mole amount of magnesium hydroxide. We need to convert that to the moles of the desired reactant, of the desired product, which in this question is magnesium chloride. 1 mole, we are converting from 1 mole of MgOH2 to 1 mole of MgCl2. Alright? And that should give us 0.0189 moles of magnesium chloride. So that's for the first reactant. Now we have to do the same for the second reactant. But for the second reactant, it is actually a solution. So we need to find out the mole quantity from this HCl solution. The key equation here for HCl, we have to start from the key equation for molarity. Now what do we know? We know the molarity right here, and we also know the volume. It's not in liters, but we can convert that to liters. So therefore, we should be able to calculate the moles by multiplying the molarity and liters for HCl. So therefore, the moles of HCl should be the molarity 0.1688 moles per liter. Make sure you use this as the unit for molarity, not just use M. Multiply by the volume in liter. We can convert this milliliter right here into 0.2315 liter. Liters and liters are cancelled. Then we should now have moles as the unit. And your calculator should give you about, after taking care of the sig figs, 0.0391 moles of HCl. And again, we have to convert HCl, moles of HCl, to the moles of MgCl2 so that we can compare the mole number produced by the first reactant, magnesium hydroxide. Okay, so let's do that. I still want to be able to see, yeah, this value right there, 0.0391 moles of HCl. We are converting from 2 moles of HCl according to this balance equation right here on top. 2 moles of HCl to 1 mole of MgCl2. 1 mole MgCl2. And what is that value? That should give us 0.0196 moles of HCl. Now we compare this mole amount with the mole amount produced by the first reactant. Which one is smaller? The one produced by the first reactant. So this one is smaller. Therefore, the reactant that yields this smaller amount should be the limiting reactant. So therefore, MgOH2 is a limiting reactant. If you forget those guidelines, again, you have to go back to lecture 22, slide number 7. You see, that's what we did. We converted the mass of the mole amounts of both reactants to the mole amount of the desired product. We already did that. The reactant that yields the lowest mole amount of the desired product is the limiting reactant. You see? So that's why we just determined MgOH2 is a limiting reactant. So then you just need to enter MgOH2 into this box. Next, how much magnesium chloride is produced? How do we find that out? Again, if you forget, you have to go back to the guideline. The mass of the product calculated using the amount of the limiting reactant is a theoretical yield. So what is asked here, how much of magnesium chloride is produced? Actually, in other words, it is asked for the theoretical yield for this reaction, for this chemical reaction, this particular chemical reaction. Okay, so we just need to convert the mole of the desired product to gram of the desired product. So that should be just a simple one-step conversion. Okay, so let's do that. 0.0189 moles of MgCl2 we are converting from moles of MgCl2 using the molar mass, which is 95.2 grams. This way, moles MgCl2, moles MgCl2, they are cancelled. That should give us 1.80 grams magnesium chloride. So I keep 3 sig figs. Again, that's because in the original question, you see the least number of significant digits, that's 3. Okay. So 1.8 grams of magnesium chloride. You can enter that into this box, then you can submit your answer. That's how you solve this problem.